This project is to study in-plane fluid elastic instability in steam generator tube arrays. I guess the interest started when there was an issue with a steam generator in the United States where they had these big expensive replacement steam generators, and during their first cycle they found that they began to leak. And on investigation they found that the tubes had started to vibrate wildly and bash into each other. And we recognized the phenomenon. We'd seen it in our lab tests, but it had been, up to that point, never observed in actual operating steam generators.
In a nuclear power plant, basically the business end is the steam generator, because that's what produces the steam that actually goes to the turbines, drives the turbines, provides electricity that powers more than half of Ontario's electricity needs. And we're very proud of our nuclear industry, but we always are trying harder to make it safe and keep the components working better and working longer with less maintenance and less inspection. The goal of this program was to make sure that any new steam generators are built will meet those exacting safety standards, and they will last for 60 to 80 years. That's our goal. So our job is to make sure that designers have the information to prevent that kind of thing from happening.
Well, I think we've taken the first steps to identify the problem that occurred in the reactors in California, the steam generators. And again, it's going to be an industry effort to take the information we've gathered and adapt it or use it in models that can be used to predict and prevent a reoccurrence of this in-plane fluid elastic instability. And it's also going to impact the design of future steam generators.
Oh, this can't be done without a team. In fact, the one good thing about this work that I really liked was that we used the lab facilities we have here. This control room is part of a very large industrial thermohydraulic loop. It's unique in Canada and maybe even in the world. And so we couldn't do it without the loop that produces freon, vapor, and liquid to mimic the inside of a steam generator. Our job was to work with the team to instrument and design and build a rig that looks like a steam generator. It's a small section, but it's enough to make the tubes behave dynamically the way we should. And that required people who know instrumentation, people who work with metal, people who do plumbing, people who do rigging. It's a thick steel wall pressure vessel, weighs quite a few tons. We had people, carpenters, dealing with the framework. We had millwrights hoisting pipes in place. We had people analyzing data, people designing computer software to access the data and analyze it. That's quite a lot of skills. So it was definitely a big team effort.
Well, I feel this is the most exciting and maybe groundbreaking work that I've done in my reasonably long career. I don't think I've ever seen different groups within the company come together as well as we did, and to make this happen. You know, both our own teams and different branches. So it's really satisfying to me. And as I approach the end of my career, it allows me to leave with that feeling of satisfaction that we've done something good.